All right. For the next two lessons, which is the end of this chapter, and it's been because we're taking a chapter test is over section 7. Okay. So on the graphing rational expressions that we were working on all last week, graphing our fractions, a little big, a little same, whatever, all of that, right? And then the second half of this chapter is going to be looking at inequalities. We're going to break it into 2 days. Today we're going to focus on the polynomial inequality. So polynomials, like what we saw at the beginning of today, x squared plus 5 plus 7, something like that. And inequality means that it doesn't have an equal sign. Not like we saw at the beginning of today, but now it's going to be a greater than, a less than type thing. Tomorrow we'll focus on a rational inequality, the fractions in those greater than less than situations. Okay. We'll review all this on Friday, Monday, and we'll take a test on this on Tuesday. Okay. I'm always just reminding you that's all for your deadline for anything in this chapter. So 2.6. Okay. All right. So reviewing what we know from previous times that you have run into inequalities. We know that if something is listed as a greater than, which is that symbol, a less than, which is that symbol, that we don't include that number. So wherever we are graphing this, we would be used as an open graph. That when we don't include things, then we use parentheses when writing our interval. That if it's a greater than or equal to, a less than or equal to, has a little bar underneath of it, we will indicate that with a closed dot. And when we are writing our interval, if it does get to equal that number, we use a bracket. That's not new to us. We've seen all of that, especially when we were talking like our domain restrictions. Remember when it's like greater than or equal to 0, or we just said greater than 0, and maybe I was doing on parentheses and brackets. So that's not new, but just reminders that's going to become very important to us today when we use brackets, parentheses, open dots, closed dots. Okay. And then this one is just kind of a general review here. If we are looking at something like some number being less than or equal to 0, what does that mean? If there's a number that's less than or equal to 0, what kind of numbers are less than or equal to 0? Negative, right? So I know that seems like a silly thing to review, but anytime that it's less than 0, whether it is or equal to or not, this means that we are looking for negative numbers. And if it tells me that it's greater than or equal to or greater than 0, the type of numbers we would be looking for would be positive numbers. Those symbols are going to be at the end of our equations, and so then we're going to interpret that every time we get to at the end of our inequalities. So we're going to interpret that every time we get to one of those and say, okay, well, what does this mean? What sections am I looking for? Am I looking for the negative section or the positive section? And it will come from this thing right here at the very end of our inequality, whether it's greater than or less than 0. Okay. All right. I know there's a lot going on, so let me explain what you're seeing in this picture. We have graphed polynomials, right? We found out the behavior, we found our zeros, whether it's going to bounce or cross through, all of that stuff. We just graphed them. But what I want to do is take a little bit closer look at this and what does that mean about our polynomial? Anytime that our polynomial was above our x-axis, which is what happened in this area and this area, that means that we are looking at positive values for our polynomial. Had I plugged something in, I would have gotten a positive number as an answer in those sections. But if it was below my x-axis means all of the values are negative numbers. They're all negative answers. These are all negative answers. Okay? And where it hits, yes, and where it hits my x-axis, which we call zeros, is where our polynomial equals 0. Well, when we're talking inequalities, we want to know where it is positive and where it is negative, but we're not necessarily going to have a graph to look at. But I want to kind of make those connections because we do know a little bit more about the graphs right now than we do know about like the inequality part of polynomials. So kind of connecting those things. When our graph is above our x-axis, it's positive values, when it's below our x-axis, it's negative values. Sometimes we're going to kind of have to rely on just that idea when we know nothing else of 421. Okay, so what I want to do now is connect this to what we are going to see called a sign chart. And a sign chart is going to look just like a number line, but what it's going to do is just help us organize our thoughts on whether or not our polynomial is a positive value in those sections or a negative value in those sections. We will not typically do it from the graph, but I want to show you like how the relationship happens here. What you're going to see on your sign chart is dots at the locations of our zeros. So like up here, I have a 0 at -2 that will show up as a dot on my sign chart. I have a 0 at 0 that will show up as another dot on my sign chart. And I have a 0 at 1, that would be the last dot on my sign chart. And these are just number lines, so they start at -infinity, go to infinity. We will just make them tailored to the particular polynomial and its zeros that we're working with each time. Okay, but then what we'll see is it will tell us what the polynomial is doing in the sections between the dots. So between -infinity and -2, our graph is below the x-axis, and what you'll see happen on your sign chart is we will identify that as negative values for our polynomial. Between the zeros of -2 and 0, our graph is above the x-axis, and what that will show up as on our sign chart is positive values for our polynomial. Similarly, between 0 and 1, it's just below my x-axis, and when we do our sign chart, you'll notice that that shows up as a negative section on our sign chart. And then from 1, the dot at 1, wherever, our graph is going to continue to be above our x-axis, and as we do our sign chart, you'll notice that that comes out as a positive section for our graph. So kind of making that relationship, but here's the thing is we're not going to see the picture of a graph. We can consider it, but it's actually more work than we need to do. Okay, but I want you to understand what that sign chart is telling you is happening. Below your x-axis, above your x-axis, below your x-axis, above your x-axis, and then answering things like where is it positive values, where is it negative values eventually. Any questions so far? Okay, so if we don't get to see the picture, how are we going to fill this in without having to like go through all of that work? To fill in that? Here's how we do this. Given the polynomial, we will get it factored, which is why we continue to factor. So this one I factored into x times x minus 1 times x plus 2. And what we will do is go through that and identify all of the zeros of that polynomial. So had I set this equal to 0, anything that has an x would give me a 0. And I go draw those dots on my sign chart. So I would draw a dot at -2, at 0, and at 1. So I translate all the zeros from the polynomial after factoring it to my sign chart. Now, I don't have a picture to look at to tell me if it's positive or negative. So here's the little trick to this. Is we are going to pick sample numbers in each of those intervals. So the intervals we are looking at would be from -infinity up to -2, and then 2 to 0, 0 to 1, and 1 to infinity. And we pick a sample number, any number that falls in that section, and we plug it in. And I don't need to know the answers necessarily. I just need to know if it's positive or negative. So this is my own personal notation for this. I hope it makes sense. But if I pick something in this section here, just a sample number. Like you could pick -3. I tend to pick like -10. Okay, something that's easy to think about plugging in. You understand how -10 represents this section? Anything in this section from -2 down to -10. Okay, so I'm going to plug in -10. That's my sample number for that section. And when I plug in -10, I'm going to go right back up here. I don't really care what the answers are. I care if it turns out positive or negative. When I plug in -10 for x, I get a negative number, right? When I plug in -10 here, I have -10 minus 1, which is another negative number. And when I plug in -10 here, -10 plus 2 is still a negative number, right? And so what it comes out is I have a negative number times a negative number times a negative number, right? I don't know what they are, but if I take a negative times a negative, I get a positive, yes? Times one more negative is going to turn out to be negative. So then above my sign chart, I put the overall, this keep doing that for every interval across here. Now, don't overthink this. What could be a sample number between -2 and 0? -1, okay? And I'm going to go through all three of those sections and plug in a -1 and decide if I would ultimately get a positive or negative number. So if I put -1 in here, -1 in for x is negative. -1 minus 1 is negative. But -1 plus 2, positive, right? Okay, so now I have a negative number times a negative number, which is positive, times another positive number, we get positive. So overall in that section, every number I plug in would give me a positive answer. This one's a little trickier because you do have to figure out like a fraction. But again, I don't need to know the numbers. I just need to know if it turned out positive or negative. But something between 0 and 1, like a half, right? So if I'm plugging a half in here, a half in for x would be positive. Ooh, slow down on this one. 1/2 minus 1, negative, right? And then 1/2 plus 2 is positive. If that were my three signs of my number, what's my overall answer? Negative. And then something bigger than what? Like 10. I could really big number, okay? When we get to the end. So I'm going to pick like 10. If I put 10 in here, it's a positive number. 10 minus 1 is a positive number. 10 plus 2 is a positive number. And if everything I'm multiplying together is a positive number, it's positive. Questions on that? All you see below is 100% my personal notation for this, not a requirement. But ultimately, you have to think through, if I plug in a number in that interval, what's the sign on my answer? Okay? Okay. That's how we create the sign chart. Now, guys, you just created a sign chart. That is the function for this picture. We didn't see that picture, but it matches. That's the same thing we just had, same zeros, same signs and everything. We just didn't see the picture to tell us where the graph was, but now I can tell you that it's below my x-axis, above my x-axis, below, above. Okay? And then ultimately we go answer the question, which we will get to on the next screen. All right. So solving an inequality algebraically. I have some steps listed off to the side for you. If it is not set equal to 0 to start with, like we kind of saw at the beginning of our notes today in our warm-up, we had to get it set equal to 0, start there. Move everything to the same side so that it is equal, not equal, but greater than less than whatever, to 0. Solve for x, you might have to factor at this point if it is not factored. We need it fully factored so we can figure out what our zeros are. Then we will create a sign chart like we did on the last page. So our sign chart will be a number line that goes from -infinity to infinity with marks at the zeros of our polynomial. Our zeros would be 5 and 3, right? You don't have to make a full-fledged number line. I just have to have those in numerical order. So I have 3 on here, and I would have 5 on here. We have a 0 at 3, we have a 0 at 5. Make sure you put those in the right order, small to big. Okay. Then just like we did on the last page, we're going to pick a sample number in each of those sections, plug it in to decide if our answer is positive or negative, and then we will finally get to the whole reading it to get our answer. Okay, so sample number. Oh, pick me a good one here. Something in this interval from 3 down to -infinity. What would be like the easiest thing to pick in that? 0. Okay, so I am picking 0 as my representative for that interval. I'm plugging it in up here. 0 minus 5, that's a negative number, right? 0 minus 3, that's a negative number. But if I have a negative times a negative, everything I plug into that section will end up giving me a positive answer. Question. Okay, let's pick a sample number. It should be easy also. Something between 3 and 5. Like 4. Okay. So again, don't overthink that. Don't make it too hard. It's on 4. Okay, 4 minus 5. Negative, right? 4 minus 3, positive. Well, a negative number times a positive number, negative. So everything I plug in between 3 and 5 will give me a negative answer. or be below my x-axis. Okay, something bigger than 5. 10. I don't know, doesn't matter. Something big, right? 10 minus 5 is positive. 10 minus 3 is positive, and a positive number times a positive number is a positive number. Okay, we've not done the sign chart twice that way. Are we doing okay with that? Mm-hmm. Out of context, this was all weird, right? Because that doesn't seem to make sense. These random symbols that are showing up below them, that's just for us to kind of think through what we're getting, right? Okay. Reading our sign chart and finally getting to step 4, write an answer. We don't have an answer yet. Write an answer. It comes from this, and this says, what does this sign tell you? Go back to what we started with at the beginning. Less than or equal to 0 is what types of numbers? What numbers are less than 0? Negative. I will always mark 2 things here because there's 2 things I can learn from them. Negative or positive, and then brackets or parentheses. Would we use brackets or parentheses here? Yes, because of the or equal to, right? So then I go to my chart and I find where it says we have negative answers. We have negative answers here, right? Which means here's my interval from 3 to 5. The interval that gave me negative answers is the interval I write down. I'm going to put brackets around my numbers because of the decision made up there because it's not or equal to. This is the section that will make this less than or equal to 0. Questions on that? Now, fast forward to your assignment. On my math app, it asks you basically to kind of go back to the sign chart and say, what would that look like? This is how they mark it. They put parentheses or brackets literally on the sign chart at those numbers. So they would show brackets here, and this is the area that made it true, right? So that's what your visual is going to look like to match to our interval answer. Questions? Okay. Just variations of that as we go. We will see a couple of unique cases where we might have to think about it a little bit. All right. X squared minus 9x plus 10 greater than 46. What's the very first thing we're going to do? Subtract 46. We need it equal to 0 before we can start doing anything, right? So the very first thing I'm going to do is subtract 46. We have to get it equal to 0. Equal greater than, less than, whatever to 0 before we can start. Okay, what are my factors of negative 36 and add to negative 9? Negative 1 times 3, which means we have zeros at 12 and negative 3. I like calling them zeros, but those also are x-intercepts, right? So when the question is, what are the x-intercepts? There they are. Negative 3 and 12. Order does not matter. Until we draw it on our sign chart, then order really does matter, right? We take this in numerical order. So from negative infinity up to infinity, I just put a mark. You can make a full-fledged number line. I don't. I just put the marks of my zeros. So there's my interval. I have an interval from negative infinity to negative 3, from 3 to 12, and 12 to infinity. And we now need to go back and see, okay, is it positive or negative in each of those sections? Something smaller than negative 3, negative 10. Perfect. Negative 10 minus 12 is something negative. Negative 10 plus 3 is also negative, which means this section is positive. So the negative number and the negative number is a positive number. Something between negative 3 and 12, pick the easy one. 0. Okay? 0 minus 12 is negative. 0 plus 3 is positive, which means this section is negative. And then something bigger than 12? 20? 100? I don't know. Something bigger than 12, right? Any number bigger than 12. 20. 20 minus 12 is positive. 20 plus 3 is positive. And a positive number times a positive number. Okay, what if I'm not understanding that? Go figure out the actual number. It's a lot more work, but you can do it. Plug in a sample number and figure out what you actually get. And then that sign is what it is. Okay, you don't have to do like symbolic. You can do actual numbers. That's okay. All right, now reading our answer. It comes from this. This is sometimes what people miss. I want numbers that are greater than 0. So which sections am I looking for? Positive. And then also remind yourself, if it does not have an or equal to, when I find those sections, I'm going to wrap them in parentheses because I'm not going to include the zeros. It's not equal to 0. Okay, we happen to have 2 of those intervals this time, which means I will have 2 answers. This interval right here is one of those, negative infinity to negative 3. Infinity has to be our parentheses, but because of our discussion up here that it is just greater than, not or equal to, I will also parentheses the negative 3. You do need to union your sets. For now, I will put a union between them. I have a second place that was positive. There's my second interval from 12 up to infinity, which is my solution interval. All right, how are we doing? The next one, and then we'll get into kind of the special cases. This one's still pretty straightforward, it's pretty normal. We got a 2x cubed minus 12x squared is less than or equal to negative 16x. So similar to what we did on the last one, it's not equal to 0. So start by moving everything to the same side. And then we have to remember how to factor this one, right? What's the first step of factoring that I have to remember on this one? UCF. Now, not only do they all have something in common as far as numbers, but they all have a variable in common as well. So you should have pulled out a 2 and an x. Because we are ultimately getting all the way to solving, if you forgot the 2, it's not going to end up changing your answer in the end. It would make your factoring a lot easier. Because now I'm only taking a factors of 8 that add up to make x. Okay. The twist on this one that we haven't seen yet, although we saw it at the beginning, is the GCF that has a variable. Remember, we'll leave it as a variable. Things that have x's give us 0. So on this one, we have a 0 at x equals 0, and x equals 4, and at x equals 2. Now, the way I have them written in the factored form does not have to match how I have them down here, right? Because we need to go in numerical order, which in our case would go then 0, then 2, then 4. Okay, now we just start picking our sample numbers, plugging them in. You have 3 places to plug them in. This is very similar to what we did at the beginning when we were first learning our sign chart. So something less than 0 would be like negative 10. Go ahead and plug a negative 10 into all 3 of those places. Negative 10 here would be negative, negative 10 here would be negative, negative 10 here would be negative. Ultimately, 3 negatives gives me negative. Okay. Something between 0 and 2 would be like 1. So now I'm going to go plug a 1 into all these spots. 1 would be positive here. 1 minus 4 is a negative number. 1 minus 2 is a negative number. Well, 2 negatives makes a positive. Times another positive is positive. Something between 2 and 4 would be like 3. Positive. 3 minus 4 is negative. 3 minus 2 is positive. Well, if there's only one negative, it's a negative number. And then something bigger than 4, like 10. Positive, positive, positive is overall positive. Reading our answers. Less than or equal to, less than 0 is negative numbers, or equal to is why we will put brackets. at numbers. Finding those sections in our picture, we have a negative here, we have a negative here. Those would be our intervals. So as I go to write my solution intervals from negative infinity up to 0, I'm supposed to bracket, but can I bracket an infinity? No. So I will put a parentheses there when I write my interval. We will union if there's more than 1. I do have another one that was negative numbers, and that is from 2 to 4. That is our solution intervals. Oops, I forgot to have zeros up there, which would be all of those spots that we put on our number line 0, 2, and 4. And the last thing is just showing that same thing on our number line with the correct symbols. We would have a bracket of 0 down to infinity. We would have a bracket at 2 and at 4, and that would represent the parts that we said made this true. Any questions for me on this? Okay, let's get into some of our unique or unusual solution sets. Because of course, we can't all just play by the rules, right? So sometimes they're just not nice. So as I look at this problem, it seems harmless, right? X squared plus 2x plus 3. 40 equals 0. All I got to do is factor it. What are the factors of 3 that add up to 2? None, right? Not factorable. Now, we're going to, at the end, I'm going to say come back to this so that we can potentially skip my next step. And if it's not factorable, our next option to find our 0 would be quadratic, right? Now, as I jump into that, I'm going to tell you why I knew I actually didn't have to do this. Okay, so as I do this, let's see. I would end up with negative 2 plus or minus 2 squared minus 4 times 1 times 3 all over 2 times 1, which ends up negative 2 plus or minus 4 minus 12. What is that type of a number? Imaginary. What does that mean? That's very important to us right now. Imaginary. Does that mean we have any real zeros or any real x-intercepts? Which means it can't hit the x-axis. Understanding that is very important. Because this is imaginary, I do not have any x-intercepts. Now let's go back to your end behavior. If this is an x squared, it's a parabola, and the ends are going to head up. Follow with me on that. Positive, yes. Okay. And if it doesn't hit my x-axis, I don't really know what this picture looks like, but I know that the whole thing has to be up here because if it was lower, I would hit my x-axis, and it's going to go up forever. So it's going to start above my x-axis and it's going to stay above my x-axis, or I would have had answers for this, right? So I don't have a sign chart to do because I don't have x-intercepts. I don't have zeros to write on a sign chart. So I have to think about what's going on in this to answer my question. My question is, where is this graph negative, right? Where is this graph negative? Nowhere. So it is okay to say no solution. There is no place that this graph will be less than 0. So there is no x values that I can plug in here that it would end up being less than 0. So this is a no solution. Now, I could change that a little bit. What if I said greater than 0? Where is this graph greater than 0? You got it. All numbers, everywhere. Everywhere, and everywhere is negative infinity to infinity. So those are kind of unique answers to a question like this. Okay. Continuing with our unique answers, somebody may have had this question in their head earlier, and we're now going to see that it does not follow this. Did anyone notice that all of our signs just like alternated all the way across? Or was anyone hoping that that was just going to always happen? I didn't have to think about it. Yeah, me too. So here's another unique solution set. We'll talk about what's going on here. I'm going to treat it like a normal one. Factors of 36 that add up to 12. Positive 6, positive 6, right? So I will have my zeros. Okay, well, that's the same number. I can do a sign chart, right? I have a 0. It is my x-axis, that's negative 6. All good so far? Okay. So look what happens now when I plug in my sample numbers. Something smaller than negative 6, like negative 10. If I put negative 10 here, negative 10 plus 6 is a negative number. Negative 10 plus 6 is another negative number, and a negative times a negative is positive, right? Okay, we'll plug in something bigger than 6, like 0 or 10. I don't care. 0 plus 6 is positive. 0 plus 6 is positive, and a positive times a positive is weird, right? Positive, and the whole thing is positive except for that. What's that? That's that right there. 0, right? Is a 0 over a function? That's why I put it in there. It's 0. This is a 0. It's not positive or negative. Any dots along there are zeros of our function. So the question is, where is this function bigger than 0 or positive? You have to be very careful on this one. Do we get to include the zeros? No. So where is it positive? It is positive here, the interval from negative infinity up to negative 6. Because I am not including the negative 6, we are going to have to break there. I don't get to just keep going because that's 0. And 0 is not greater than 0. We don't get included. And then we have a second interval that is also positive, and that would be from negative 6 to infinity. Questions on that? Since we already did all the work for this, I want to just give you some little bonus question here. What if I did change it to greater than or equal to 0? If it's greater than or equal to 0, this would change into what symbol? A bracket. But if I get it included, we even really need to stop there. So here's a concept that we're going to talk about on the next page, is if I get to include the 0 and neighboring intervals are the same sign, I don't have to break there. Which means if I need everything that is positive, which would be those two intervals, and everything which is 0, which is that one number, isn't it just everything in this picture? So notice the difference in how I would have answered this if it had the or equal to on there. What if it had said less than 0? Do we have any sections less than 0? No. No solution. But here is your, is less than or equal to 0 also no solution? That's a trick. They're not a trick question. That's a tough question. Is less than or equal to 0 no solution in this problem? It is not, but does anyone know what the answer is? Negative 6. There's one spot that it is or equal to 0, and that is at negative 6. When it is a singular number, you can put it in brackets or curly brackets, both mean the same thing. But there is actually one little answer to that without making it true. Okay? Any questions on that? All right. I have 2 more weird cases. And that is when we start seeing exponents. So we're going to look at 2 of these where we see some exponents. I've done all the hard work. I've got it equal to 0. I've got it factored. And we are going to talk about how to speed this one out after this example. So, I know I have zeros at -2, add 1, subtract 1, divide by 3 at -1/3. The nice part about these sign charts is even if we end up with kind of some ugly numbers on there, like -1/3, I don't doesn't necessarily pick ugly numbers between those to represent that number. Okay? Their class is way more fun than ours today. Those are all zeros, right? Or excellent. Pick sample numbers. You can treat this just like you would. Pick a sample number and I want you to see if you can speed this up by the end of this. If I pick like -10. Okay, -10 plus 2 is a positive number. I mean, that's the line. -10 plus 2 is a negative number. But then I'm going to take that and square it. Positive, right? And then -10 minus 1 is a negative number. What happens when I cube it? Stays negative. And then -2, that'd be -30 plus 1 is a negative number, but then I'm going to square it. And when I square it, it comes back out positive. So we have a positive, a negative, a positive, overall is a negative. Okay, good so far? Take something between -2 and -1/3, like -1. -1 plus 2 is a positive number, squared stays positive. -1 minus 1 is a negative number. Cubed stays a negative number. So that'd be -3 plus 1 is a negative number, right? But then squared is positive. Yeah. Okay, so then a positive times a negative times positive is negative. Okay, so something between -1/3 and 1, like 0. So 0 plus 2 is positive, squared is positive. 0 minus 1 is negative, cubed stays negative. 0 plus 1 is positive, squared is positive, and then overall again be a negative section. Something bigger than 1 is like 10 plus 2 is positive, squared is positive. 10 minus 1 is, this is finally, 10 minus 1 is positive. Cubed is positive, right? And then that's a positive number, squared is positive. We finally get a positive section. So we want the sections that are less than or equal to 0, so negative, bracket. When they are next to each other, that bracket means we do not have to break. So what is our solution to this? Negative intervals. Very good. Because it would be a negative interval here, negative infinity to -2, but we can include that so I don't have to break here, and the next one's still also negative. We just keep going. Well, the next one's also negative, and we keep going until we would stop and switch to positive. So it is from negative infinity to one. Very good. If I take away that we're equal to, we would have to break any of the zeros, right? So it's a bracket here. All of that would be our solution. I just want to tie this to what this looks like. You would have had zeros at -2 and -1/3 and at 1. It is an x, if I put all that together, it's an x to the 7, so my ends go like this. Because of the even multiplicities, it would have bounced at -2, it would have bounced at -1/3 and crossed through at 1. You see how all of this is below my x-axis, which is all that negative interval there. That's what just happens. Okay. Now, can you speed this up for me a little bit? Do you notice what was happening based on our exponents? What about all those ones that had a square? Do they even really need to know what number is in there? If it's squared or raised to an even exponent, isn't it always positive? So if I speed this up even faster on this next one, watch what I do. I have a 0 at 5, at -2, and at add 3 divided by 2, 3/2. I know because this first one is an even exponent and that last one is an even exponent, all of those answers will be positive, right? So the first one and the last one will be positive. I just need to know what's going on here. Okay. So I really only need to consider that middle one or anything that has an odd exponent because the odd exponent will keep whatever sign is in there. So when I plug in a sample number of like -10, I really only need to consider is -10 going to be a positive or a negative? And then multiply by the two positives will not change the sign, right? So a -10 minus 2 is negative, that's a negative fraction. Speed this up by just having to consider one. Anything that has an odd exponent is all I have to consider if we have exponent. Does that make sense? So on this one, I do want to finish it out really quick. So like 0 plus 2 is positive. 4 plus 2 is positive. So these would all be positive sections. Finding where this is greater than but not equal to 0 means I'm going to have to break out my zeros. So notice the difference is my although these are neighboring positives, because I do not have the or equal to, I will have to break into those. So -2 to 3 has break because I don't get to include 0, so I have to break every 0. 3 has to 5 break 5 to infinity. Okay, that's about as all the unique ones I can figure out for us. Questions? We are back to a My Math Lab assignment. You're going to look at number 40. I think I have 41 on there as well, but that's tomorrow, so just 40 today. We will go through any questions that you have on that before we get into tomorrow's assignment or tomorrow's notes.